Okay, the one new little piece that I want to talk to you about for just a couple of minutes is what's called free-falling objects. So this is an object that I drop or an object that falls. Okay, so it's an object, when we say free, it means there's no string attached to it, there's no one holding on, it's just free and falling. And usually these free-falling objects fall from rest. And if they fall from rest, that's going to mean their VI is 0. So always watch for that. They won't tell you, but if they're saying an object is free falling or falling from rest, and in physics we often call our objects bodies, but I don't want you to necessarily think that they're really bodies that are falling. It could be a rock or a book or whatever, okay? Or it could be a body. And whenever it says near the surface of the earth, then that means that gravity, the gravity that we know is acting on it, and that gravity is going to cause it to accelerate. And if we're at or near the surface of the earth, that acceleration will be 9.81 meters per second squared. So the question won't tell you that. The question will assume that you know if it's falling, that its acceleration is 9.81 meters per second squared. And it's always, 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 always going to be downward. Whether the object is being thrown up in the air or it's falling from the roof, the acceleration gravity always pulls us down towards the center of the earth, no matter what. That is something you can count on. Okay, so if the question states the object is falling or dropped, then it's understood that the VI is 0, and it would be understood that the acceleration is 9.81 meters per second squared. But the same equations apply, our new equations that we're just getting to know and love. So let's take a look at example 1. Find the distance, and you have this sheet, I gave it to you in class. Find the distance traveled, okay, so we're looking for delta D, and the final speed, so we're looking for VF, so this will be like part A and part B, of an object falling from rest for 10 seconds. So falling from rest, VI is 0. 10 seconds, delta T is 10 seconds, and because it's falling, A is 9.81 meters per second squared down. Now, a word about the up and down. As long as everything is going down, like it is in this question, the object's falling and gravity's pulling it down, we can just call down positive. Okay, so earlier I had said usually up was positive and down was negative, but that's true when they're in the same question. But if the only direction in a question is down, well then make your life easy, call it positive. If you start calling it negative, you'll have negative signs to lose. So let's call down positive, and I want to find delta D. I have VI, I have delta T, I have A, so I can just do delta D is equal to VI delta T 1/2 A delta T squared. The VI is 0, which means this whole front term is going to be 0. And I'm looking for delta D, so 1/2 9.81 meters per second squared, and the time is 10 seconds squared. 10 squared is 100. 100 times 9.81 is 981, and take half of it, and you get 490.5 meters. Okay, and that will be down. It works out to be positive because remember we were calling down positive in this question because it was the only direction. If I had wanted to call down negative, I could have put a negative here in the 9.81. This delta D would have worked out to be negative, and I would have said, okay, the negative means down. But I didn't. Instead, I said, let's call down positive. All right, we now need to find our VF. You can find your VF two ways. You can realize that A equals VF minus VI over delta T, and you can rearrange that. Or you could do VF squared equals VI squared plus 2A delta D. I'd probably go with the A equals VF minus VI over delta T. It's true you have to rearrange it, but then I'm not dependent on this answer that I just found that I could have screwed up. Okay, my VI is 0, so this will go to 0. I want my VF alone, so multiply both sides by A delta T. A is 9.81 meters per second squared, and the time is 10 seconds. So VF is going to be equal to 98.1 meters per second. Again, it will be down. Okay? All right, now let's make the next one just a little bit trickier. Oops.
Angel DeLong, your drive is waiting for you out front. Angel DeLong, your drive is waiting out front.
Just in case you were wondering. A ball is thrown up with the speed of 5 meters per second. Okay, so my VI is 5 meters per second up. How long will it rise? Well, it's going to go up until gravity, right? It's going to go up, but slow down, slow down, slow down, slow down. So that somewhere up here, the VF will be 0. Okay, it's going to go up until it stops. The acceleration will be gravity, 9.81 meters per second squared down. So now notice in this question, we have an up and a down. Now we have to call down negative. And it wants to know how long will it rise. You're looking for delta t. Okay, well, if you have A, VF, VI, and you're looking for delta t, you can use A equals VF minus VI over delta t. Rearrange for delta t, bring the delta t up and the A down. So VF minus VI over A. So delta t equals, VF ends up being 0, so you could either cross it out, or if you want, you could write 0 here, minus 5 meters per second. And it goes in as a positive, that's the subtract sign. And now A has to go in as a negative because it's down. So negative 9.81 meters per second squared. And when you do this, you get a delta t of 0.5097 seconds. So that's how long it goes up. Okay? What will be the maximum height reached? This time you're looking for delta d. You're given a VF, an A, and a VI, so you could, and looking for a delta D, so you could use delta D is equal to VI delta T plus 1/2 A delta T squared. But you'd be dependent on this time. I'd be more tempted to do VF squared equals VI squared plus 2A delta D. Either equation will work, you will get the same answer as long as you haven't screwed this up. So I want to solve for delta D. So it'll be VF squared minus VI squared equals 2A delta D. Divide both sides by the 2A. So VF squared minus VI squared over 2A. So delta D equals, well, the VF is 0. So it'll be subtract VI, 5 meters per second. And that gets squared over 2 times negative 9.81 meters per second squared. So when the top is negative 25, on the bottom is negative 19.62, which is going to give us a positive, and when you do the math, 1.2742, I think, meters for the delta D. Works out to be positive because it's going up. C, how long after it leaves your hand will it return? Now here's the cool thing. When you throw an object up like that, it's going to slow down, slow down, slow down, slow down until it stops, and then it's going to turn around and come back, speeding up, speeding up, speeding up, speeding up. It will be perfectly symmetrical. We found the time we found here in A was the time it takes to go up, so the full time, the total time will be just 2 times that, because it will always be symmetrical. So you can just double your 0.5 there to get your total time. And so it should be 1.0194. I think it's 38 if you keep all your digits. Okay? What will be the speed? What will the speed be in 20 seconds? We're going to run out of time here, but we're looking for the VF. We're looking for the VF when the time is 20 seconds. And we have our VI and our A. So use A equals VF minus VI over delta T. Multiply by delta T. A delta T is equal to VF minus VI. So VF equals, what am I looking for? What will be the speed? Yeah, so VI plus A delta T. So VF equals 5 meters per second plus negative 9